Welcome to the AI Research Roundup. I'm Alex, and today we're looking at a paper from the Hugging Face trending list, published on July 6, 2025, so just 2 days ago. This paper introduces a new model for robot manipulation that achieves a 76.7% success rate on real-world tasks. The paper is titled DreamVLA, a vision language action model dreamed with comprehensive world knowledge, and its approach to planning is what really sets it apart. The core idea is that instead of predicting future video frames, the model forecasts key world knowledge to inform its actions. Also, the authors shared their implementation on GitHub, and it's quite complete. You'll find the full source code, scripts for training and evaluation, and detailed instructions on data processing and setup. So if you want to get your hands dirty with DreamVLA, everything you need is right there. Alright, so to really understand what makes this new approach different, the first figure lays it out perfectly. It compares DreamVLA to other vision language action models, or VLA models for short. These are models that take in visual data and a language command, and then output a physical action. Older methods either directly map inputs to actions, or they try to predict an entire future image, which can be inefficient. But DreamVLA, it predicts a compact summary of key information, what they call a world embedding, which includes dynamic motion, 3D depth, and high-level semantics, or the meaning of objects. Building on that idea, this next figure shows the model's architecture. At the bottom, you see the inputs, a language command, the robot's physical state, and what it sees. These get processed by a large language model. Now, here's the key part. During training, the model uses special dream queries to create that world embedding, and then tries to predict future dynamics, depth, and object meaning. But when it's time to actually perform a task, it skips those predictions and uses the rich world embedding directly to generate an action. This makes the process really efficient. So, a key challenge is managing all these different types of information. You have language, motion, depth, without them interfering with each other. And this is where the model uses a clever technique called blockwise structured attention. This grid basically shows how different pieces of information can interact. The gray squares mean they can talk to each other, and the white squares mean they're blocked. By masking the attention between the dynamic, depth, and semantic information, the model keeps them separate during training. This prevents noise and ensures the final world embedding is clean and well organized. So, does this structured approach actually work? Well, moving to the results, this table shows a head-to-head comparison on the Kelvin ABCD benchmark. The key metric is average length, basically how many tasks a robot can complete in a row out of 5. To generate those actions, the model uses a denoising diffusion transformer, which builds up a coherent action sequence step by step. And looking at the numbers, DreamVLA gets a score of 4.44, a big step up from all prior methods, confirming its unique world knowledge forecasting really works. Alright, so that's the simulated benchmark, but how does this translate to a real robot? Well, this table shows the evaluation with a physical Franka robot on tasks like picking up objects, placing them, and opening and closing a drawer. The numbers represent the success rate, and again, DreamVLA is the clear winner. It achieves an overall success rate of 76.7%, which is a massive improvement over the other methods. This really confirms that forecasting world knowledge isn't just a theoretical benefit. It leads to much more reliable performance in the real world. So to really understand which parts of this world knowledge are most important, the researchers did an ablation study. An ablation study is where you test a model by systematically removing its components to see how each one affects performance. This table shows exactly that. The baseline vision language action model completes about 3.6 tasks in a row. But just adding the prediction of dynamic motion regions boosts that number significantly to 4.32. Then, adding depth and semantic information on top pushes the score even higher to the final 4.44. So to wrap things up, the big idea here is that instead of just predicting what the next video frame will look like, DreamVLA forecasts a compact set of world knowledge, motion, depth, and object meaning. This creates a much more robust perception prediction action loop, leading to state-of-the-art results in both simulation and the real world. It's a really promising step towards more capable and intelligent robots. That's all for today's AI Research Roundup. Thanks for tuning in, and we'll see you next time.